Right. All good. All right. Um, so I guess maybe we should just go ahead and start the meeting. I didn't do too much this week as far as any work related to the PPO paper. Um, I did. So I would say probably Rosalind should give a presentation for this week because he has done a lot of work. Did some experiments, I know, with the observation normalization. But after that, this week I did give a presentation on using DQN to train Artari. I have some interesting visualizations as well, and some bug fixing experience, which is kind of interesting. I was just scratching my head against it. So, does that sound like a workable schedule for you guys?
Sure, no problem.
All right, let's go ahead and do that then. Rosalind, do you want to go ahead and share your screen?
I'll need a moment for that.
Do you, what was that?
I just need a moment to do
Oh,
that.
take your time. Take your time. I can share my screen to show you guys a sort of a preview of what the things look like. Not this, but yeah, this chart. So it actually took quite a while to tune this to make the DQN work with the convolutional neural network for whatever reason. I don't know whether there was a bug. I try to compare this file with the file that I had. It's kind of hard to pinpoint bugs, but it should be easier once I try some other things next week or whatever. But on the top left of the screen, you can kind of see it that eventually the agent learns how to play pawn by um, sort of exploiting this pattern of behavior where it's always hitting this path of the shots. But yeah, eventually it learns, and you can check it out that in the beginning it was performing very poorly, but eventually it learns to play the game.
Nice.
Yeah.
So last week you said there was a bug, but in the end, what was it? Was it the CNN network?
Right, so that's actually the tricky part. It's hard to pinpoint. We can actually take a look together if you want. Because for me, it's kind of interesting. They almost look identical, but in actuality, the training performance is drastically different.
I see.
So let me think. Let me see. It's here, where I'm looking at here. Right? Yeah, it's here. And what's the file that I had? Which is probably this. Well, the problem is I have so many files when I was trying to make things work. It's hard to figure out exactly which one it is, the one that I was having issues with. I'm gonna stick to this one. Right, so on the left-hand side, it's the script that worked, and on the right-hand side is the script that didn't quite work. A couple things that I noticed right off the bat is that the epsilon exploration strategy is a little different. Right. Yeah, so this one is using more of it sort of has a curve. It's more like, if you notice my cursor, it's more like this. Actually, you can see it in the training graph, right? Yeah, this is the epsilon greedy exploration.
It's
Actually,
maybe too fast, right?
it is too fast, but it works just fine. Like here, it's a straight line. So the epsilon greedy is it's not even an issue. Yeah, I really need to further investigate into this, but for the most part, everything is pretty much the same. Deleted the values, that's fine. Uh, I mean, yeah, everything stays the same. I mean, one of the things that I bet is sort of problematic in the beginning was the amount of pre-processing you have to do. Like, if you look at the some of the scripts at work, they always have crazy amount of pre-processing, and it's very hard to pinpoint exactly which pre-processing is important. Like, they have this max and skipped environment fire resets. A lot of them apparently turn out to be important, but it makes debugging kind of difficult. There's
Indeed.
yeah, there's also some issues with the time limit environment. So time limit is like a gym wrapper that wraps the environment. But because of the script that we want to set up recording video, in order to set it up, you almost have to wait the environment to finish. But if you want the environment to finish, you have to use a time limit wrapper to wrap it around it. You can't just call the reset function of the environment. If you do, the monitor wrapper will not work, and suddenly you couldn't record a video anymore. So that was a huge issue. And the way that I was handling in the script that didn't work was to generate the environment and then get the unwrapped environment, which is not within the time limit, and then do all of the pre-processing and eventually add the time limit back, which may not have caused the issue.
I think the order is pretty much the same, so it should not.
Yeah, it really should not, but
But who knows? Yes, who knows?
yeah, who knows? It's very frustrating. Like, also with the seeds, once you add all those wrappers, somehow the seeding doesn't work. It's like every time you get unreproducible results, so that makes debugging very difficult.
Mm. So maybe the wrappers actually override the observation space again.
Yes, I think.
Uh,
Yeah, and
but
that's.
it works once you have used all the wrappers, right? After buffer, wrapper, and
hmm I
is
think
it okay?
I think at some point I probably tried it, and it still wasn't exactly reproducible for whatever reason.
Or maybe it's the stochastic nature of the game itself. No.
It could be, but they really should add the seating. And also by inspecting their official repo, I think they did put into some seating to the to ensure that the Atari games are the research, the gameplay are reproducible. But at least when I tried it, I tried everything, and yeah, it's taken a lot of time, and it just wasn't working. The seating part.
I see.
But yeah, I like to have things work that works, even though sometimes it's hard to pinpoint exactly what went wrong. And for the most part, the code looks very similar, so I'm kind of happy with that. But I would be interested in knowing exactly what went wrong and sort of standardize every the code to make it to make it look more consistent. But that's sort of a next week kind of work.
Okay.
Yeah, but anyway, feel free to jump in. Rosalind, feel free to take over the presentation. I think it's your time now, man.
Okay. I'll do your scripts. Sure.
All right. Did you just
I
ask?
for,
Did you ask
I
me?
forgot. I forgot how to share the screen.
Oh, right. You put your cursor to the top right corner, and there's gonna be. Yeah, there you go.
Oh, can you see the screen? Yes.
Yeah.
Ah. Okay. Good. So I think we already discussed it a little bit in the Slack this week, but I would like to start with the approximate KL, or the KL based early stopping, if you don't mind.
Mm-hmm.
Well, basically, what they do is they set it's inspired from the OpenAI spinning up implementation.
Mm-hmm.
So they have this target KL hyperparameter,
Mm-hmm.
which is quite low actually.
Mm-hmm.
Where
Okay.
is okay? So it's like 0.015.
Oh wow, that's very low. Okay.
Yes. And I wonder how the policy managed to update itself while still update itself efficiently enough. So in this training loop
Mm-hmm.
where we have the policy, once the approximate KL, which is estimated like in this way,
Mm-hmm.
basic stuff, it always breaks. And when you check the where is it? For example, this one.
So is this one training with the KL?
Yes, with the KL. The
Okay.
default implementation I used in the CleanRL uses the KL. I should probably commit it sometime. Okay, so
Okay.
it's really random actually.
Oh, that's
So I guess
interesting. So those are the iterations that is
oh
stopped
yes,
training.
mm.
Okay.
I set it to update for each epoch. We do 100 updates for each of the policy and the value network,
Uh huh.
and sometimes it manages to update till the end. Well, sometimes not. For example, in this part,
Mm-hmm.
and the return, the effect on the return, well, it's a really bad policy. In that interval, the return is already really
Wait,
bad.
I'm sorry. Could you explain one more time what does the PG stop iter mean?
PG stop in the update in the policy iteration
Uh huh.
in this loop. Once we have stopped updating the policy,
Uh huh.
I log this I epoch pi.
Uh huh.
Well, which is the iteration the policy training was stopped.
So the PG stop iteration is really the number of iteration when that was used
So,
during the training.
how many iteration could we make until the KL divergence was reached, like the threshold
Okay,
was reached?
I see. I see.
Yes, but unfortunately, I do not think it brings much insight.
Okay.
And if we refer to the original
Wait. So
PPO implementation,
mhm.
yes,
Could you go
they
back to the website? So in the PG step iteration, so is it basically the case that as long as as soon as it sort of does this update that exceeds the KL divergence, the target KL divergence,
mm,
then the performance just decreased so much as shown in the episode rewards graph.
uh, actually, yes, you
Okay.
could say so. Once the because for example in this interval
Mm-hmm.
the divergence is almost always broken
Right. Right.
really
Right.
fast.
Uh huh.
So policy is probably in a weird state and it doesn't give good results anymore.
Right. Right. That's very interesting.
And what makes me kind of worried is that they do not use such a method in the original paper, if I'm not mistaken,
I
because
don't.
they say the
Mhm.
trust region is guaranteed or maintained by the loss clipping,
Uh huh.
no, like the advantage function clipping or something like that.
Mm-hmm.
But when obviously I tried without the KL divergence, I think here the KL divergence group is in yellow is without the KL,
Okay.
and almost all the four games I tried, it doesn't give a good performance.
So
So
without the KL techniques,
yes, without the KL, it basically doesn't work, or at least my implementation doesn't work.
right, right, right. So the takeaway is sort of the KL technique is sort of effective, right?
Yes.
That's very interesting. Okay.
How
And
about in your implementation?
mhm. And by the way, oh, so what happened to the yellow one? So those are the one without KL divergence, right? without the KL technique.
Yes, to
Oh,
yellow, orange.
okay, that's interesting. So they just kind of their performance just degrades so hard.
It also depends on the game, I guess.
Right,
Here
right.
is humanoid, so at the beginning it's actually, well, a little worse than the standard one,
Uh
but
huh.
then it beats it and then falls back again.
Right, right. That's kind of interesting, but also I think I ran the experiments on the humanoid bullet inv with just regular PPL, and it doesn't seem to perform that badly. You know.
You get at least 500 points, right? Or something around.
Let me double check.
Wait, I can actually
Yeah,
probably do
yeah.
from
Could you?
here.
Are you going to check it on your end? Yeah.
Yes.
Let's just
Is
do
it
that.
it's this one, probably.
Yes. Yes, I think so. So yeah, humanoid. So
And we
those are
have PPO.
yeah, PPL continuous action. So those are without GLEs. Oh, it's actually performing not very good. So even though it's you can see that it learns, but it only learns to a certain point and just doesn't improve at all.
Yes, exactly.
Yeah, that's very
Also,
interesting.
in this case, the version that uses the KL actually manages to learn something up to 100 points.
Okay. I'm gonna check something real quick because last week I also did this experiment with the reward normalization, and I want to see because I also ran the experiments on the what's it called um, the environment. Wait, so was this humanoid?
This seems to be humanoid too.
Humanoid bullet and V0, I suppose.
Yes, V0.
Okay, that's interesting. Oh, so yeah, yours performs so much better. The ones that I have. Um, right, I can also share my screen. By the way, you don't have to stop sharing your screen
Yeah,
because
I know.
because we can do it at the same time. If you look at my screen, this is the experiments that I did for the humanoid with the reward normalization. It's
Yes,
the best one that it could get is just around zero.
I see.
So yeah,
Reward normalization, in my case, yeah, it's also zero. Even the version that was working previously, like the normal KL with the KL divergence early stuff.
hmm hmm. Also, I just realized there might be a problem with the recording. It's kind of making me nervous right now. Normally, I log into the Google Hangout by using the Firefox because it think at some point if you try to record everything by using the same browser, the frame rate kind of suffers. But we're probably gonna have to stick with that anyway.
Okay, so that was, I guess,
The
the KL
experiments.
divergence discussion.
Okay.
I don't know if we should stick to using this technique because that's probably what maintains the trust region. If you think about it,
Yeah,
in the
that's really just a hard limit. Really trust region enforcement. If you exceed, don't worry about it. I'm not gonna update.
I see.
That's pretty interesting. I think this would be a valuable technique to include in our final PPO
Yeah,
PPO algorithm. Although I think it probably makes sense to create like a separate PPO files. Like so, right now all of the files are in the experiments folder, right? We should probably at some point when we integrate this change into the main repository, we should probably create something like a PPO continuous action. I don't know. With
yeah,
optimizations, something like that, because it feels different than just the PPO algorithm, you know.
sure, no problem.
But that's something to consider in the future.
Yeah,
Great work, by the way.
yeah, not a big deal. It's basically copy pasting and running stuff.
Right. Have you
So
got it?
next,
Go
yes,
go ahead.
next I was going to. share a little bit about how I tried to, at least attempted to use the observation and the reward normalization
Mm-hmm.
based on that paper,
Right,
like
right.
the code for paper repository.
Mm-hmm.
So in this case, I just basically imported their environment wrapper.
Mm-hmm.
This is the part of custom environments. I
Uh-huh.
tried to keep the seeding working somehow,
Mm-hmm.
and then, well, using their filters,
Mm-hmm.
well, use parameterization to
Mm-hmm.
activate the filters to do the experiments. And in
Uh-huh.
this case, I still do not reset the reward filter. By the way,
Uh-huh.
did you find the
S-
conclusion to that problem?
So I don't think they've replied to my issue that I posted on GitHub.
Yes,
Uh,
I saw it.
maybe it's helpful if I send the first author an email. Maybe he'll reply.
Oh,
But
see.
but yeah, it's kind of unfortunate.
And I think I also have to get a better grasp at the way they normalize, because I think they use not the standard normalization technique,
Mm-hmm.
something that
Right.
they only use the STD, the standard deviation,
Uh huh.
to divide. They do not use the mean, or maybe my understanding is a little bit shabby.
I think that's what they want for the reward normalization. They don't want to. So what they do is they minus the mean divided by the standard deviation, but eventually they add the mean back.
They add it back.
Yeah. So essentially they kind of don't touch the mean, if that makes sense.
Okay. Uh, I want to open the paper really quickly to ask you about something.
Okay. Go ahead. Nice
So,
nice theme for the Slack, by the way.
theme is the default one, right?
I don't know. It looks different than mine. Definitely.
Maybe it's just the environment.
Yeah.
Okay, so where do they do this? Also, when they use this, the RT in this case is it's the return, right? The
Right.
final
Right.
return.
Yeah. It's not the
And
rewards.
but they use the discount like in a backward way, so
Uh huh.
uh, it's actually inverted, right? It's supposed to be the future discounted return, but in this case, it does look like a past discounted return.
Oh, that's a good point. Yes. Let me think about it real quick.
Oh, it doesn't have to be now, but it's something that was bugging me when I was reading the paper. Anyway, I go back to the.
I think you're right. It's like past discounted rewards because it's t minus one instead of t plus one. That is kind of interesting.
But yes, once I imported the environment, just use it to wrap around. And interestingly enough, I tried to check the normalization, well, the observation and the rewards, if they
Mm-hmm.
were actually normalized, but it doesn't seem to work because sometimes, or maybe it's just that way. For
Uh-huh.
example, in the observation case, I will get something like 1.00, something like that.
Uh-huh.
Maybe it's working, but I don't know if it's all right.
Yeah, with the normalizations, especially when they don't reset the running stat or the rewards, it gets kind of weird. It's because there's so many histories buried in. You know.
Maybe it's that kind of bug, like the Python bug. When you do zero point 0.1 plus zero point 0.2, you get 0.3.
Right. Right.
So maybe it's that. I don't know.
Yeah.
Actually, even especially in the PyBullet environment suite, I think the observation are already normalized by default. So
Mm-hmm. Right. Right.
maybe because they used Mujoko, they had to do such kind of pre-processing, but in our case, it might not even be necessary.
Oh, I see what you're saying. Yeah, that might be very possible too.
Okay, so when it comes to the experiment result, actually I should probably rerun it because well, all everything that uses normalization fails. Yes, although there is no change, no further change to the algorithm itself.
Uh huh. Right. Right.
In blue is the standard version, like the final PPO version
Uh huh.
using KL early stopping. The one that's worked good uh, gets around 2000, but in the other case, no,
Uh huh.
no progression.
Now
So I feel,
for the blue one, did you do the KL technique?
yes, it's the one that works best for now. So yes,
Okay, I see.
uh, actually, while I'm at it, this is a hopper. I want to check one more time how it fares. Right. This the blue one is the no with the KL, and the other guys are without the KL.
Okay, I see.
So I would say the KL is actually quite important.
So the KL, as far as our experiments goes, for now, KL seems to be the one of the best techniques that we tried because it works across multiple environments and it has a fairly stable results, right?
Yes, exactly.
That's very interesting. Good, good, good.
Okay. So let me come back. Observation. Well, this is a hopper, no result. Same as Walker. Actually, the curves are almost the same. So I'm pretty sure it's another kind of bug that's occurring.
Uh-huh.
But unfortunately, I did not have much time to.
Yeah, I remember when I started working on continuous action spaces, one of the problems that I had is the reward. It's almost a policy gradient is going to the opposite direction. So the rewards is always getting worse and worse.
Uh,
It's pretty funny that you're having the same issues with these normalization techniques.
Maybe with the normalization, is the signal, the reward signal to update the policy still strong enough to nudge it toward the good direction? I wonder.
Yeah, I don't know. I also feel like maybe the next step for us would be to sort of what's it called to try and see if we don't. Sorry, I was a little distracted by the feature that you were showing me. Right.
What
Sorry.
feature?
Yeah.
No,
Sorry.
I'm just searching for a specific run.
Yes, yes. So I was gonna say maybe the next step for us to implement as many techniques as possible, and then just run it, because the ablation study that was showed in the paper really is, implementing all other techniques, and if I don't implement this specific technique, what's the result? Not like the experiments that we did, you know.
I see.
But I have no problem, I guess, having to sort of investigating into each of those technique individually, especially. Excuse me. Especially, I want to sort of do this slow and in control instead of trying to speed everything up. There's a lot of other things that's kind of keeping me busy for the past few weeks. So I maybe just go ahead and implement every techniques, and then the experiment would be too much work for the next week. I think maybe it will be helpful. Of course, it's up to you. Do what would you like to experiment, but I think for me the next step to aim for is to probably just actually I want to experiment with the atom learning rate annealing, and so that was one of the techniques that also resulted in a significant change in in the rewards of the agents. It seems to be such a easy idea, I suppose. I'm interested in seeing if that would um in our implementation, would we able to reproduce their level of success. So I think if you scroll down for some further pages where they show the experiments, yeah, up there,
This one,
yeah, you see the annealing and without annealing. Yeah, it's a huge
es-
difference.
especially as the training goes on.
Yes, yes, absolutely.
So intuitively, I will say that using the annealing is somewhat similar to the KL divergence because
Yes.
if we have a really small learning rate, even though we make, for example, 100 update iteration update,
Mm-hmm.
well, English is broken. Okay, so even if we do 100 iteration, the
Uh-huh.
policy will not actually diverge that much from the original one because the learning rate is smaller. So
I see, I
it
see.
actually makes quite a lot of sense now that I think about it.
Yeah, yeah, yeah. Now that I think about it, and it feels like it works in tangent with the KL divergence technique that you were mentioning, because they kind of go hand in hand, you know?
I see that.
Yeah. Oh, so maybe for that, it probably makes more sense for you to work on that if you're interested in.
Oh yeah,
Um,
sure. I'm planning to try all those out.
okay.
I'll see if the observation normalization can be stabilized, well, rewarded too,
Uh huh.
and from there on, probably the Adam learning and kneeling, and as actually this one is wait, value function clipping, original fitting. So this is actually for the value function itself, right? Not
Yeah.
the policy.
Hmm. I personally wouldn't worry too much about that. In their experimental results, they didn't have good evidence that the value function clipping is causing the significant improvement in the performance. But feel free to try.
Or is there what page is it?
Yeah,
Do you remember the page?
it's the same experiments that we were reviewing before this. So remember the atom annealing. So the first one on the left, that's where the value clipping. You see, the value
Ah,
clipping is
I
not
saw.
doing anything.
I thought it was observation normalization. Okay, okay. Value clipping. So yes, actually, it does not help that much.
Yeah, it doesn't help that much. But it's if you have the effort and interested in investigating, feel free. I think it would be very interesting too.
If I like to torture myself, you mean?
Yes, yes. I think okay. I think I'm gonna try to look more into the reward normalization part. Specifically, I'm gonna try to reset the running stats. I'm gonna do some
Sure.
experiments with resetting the running stat and some experiments with resetting the the returns. Um, I'm gonna try those two things and a combination of them and see if I can sort of reproduce the reward normalization and how it helps with the learning.
Okay, I see. In this case, I will probably focus more on observation normalization,
Okay.
and if I manage to finish it quickly, the Adam annealing rate and learning rate annealing.
That sounds good.
Okay.
Yeah. By the way, I think Adam learning rate annealing should be something simple. You just get the
Yeah,
linear schedule from the DQN
something like
file.
the epsilon annealing. You
Yeah,
showed it, right?
you can just have like a linear schedule that decreases from I don't know 0.0006 to 0.001 or something like that with as time steps goes on, and then you just use that learning rate to for the
Yes.
optimizer. Yeah, it sounds like something that is so simple to implement.
Okay, sure.
But yeah, let's do that. Try to see how it's gonna work. But yeah, let me think. What else is there to talk about? I kind of have an interesting bug. If you want to, if you want to know what it is,
Okay.
so it's not a bug exactly. It's more like something that's just happens to be how it is, I suppose. So if you, let me see. Oh, this is not mine. Actually, it is. Wow, this must be an early version of my things. Very interesting. Okay. Anyway,
You're
uh,
doing archaeology, code archaeology.
Cord. What was that?
Archaeology? Wait, archaeology? Oh,
No idea what you're saying, man.
like what do scientists do in Egypt? Like digging old graves and
Oh,
finding
archaeology.
archaeology. Right,
archaeology. But my bad.
right.
Please.
So if you see this, right, you create a categorical distribution based on the logits, something like this. Probs equal to a categorical of x. And then you can do x dot sample, right? Sorry, probs dot sample to sample an action from that, and then you can say probs dot log probabilities of that particular action. Well, in this case, a different action. Let's name it some number. Oh, sorry, I need to do something else. So if I do x equal to that, and then I have to set require grad equal true. And now I do the probability distribution again, and then do the log thing. So you see it has a gradient function.
Mm-hmm.
And then I'm just going to call it y for the moment. And then y has a gradient function, right? The problem is, so there's some issues when I was running into indexing. So if I do torch.tensor and just call y, that's interesting. It's giving me some sort of warning right now, but in the scripts that I was writing, it wasn't giving me any warnings. And then when I created the result, it just this without a gradient. So for a long time, I was optimizing over the policy without the policy gradient. So needless to say, all those computational power would just went to waste. So it's a good thing that they're warning you right now, but they were not warning me. I'm actually kind of mad because of this. But yeah, that's a bug that I just
But
figured out.
wait, why would you do torch tensor? Why? At what point do you use such a method?
So you wouldn't. I had a special use case where instead of having one log probability, I have multiple log probabilities. It's all
Really? Batch?
no. It's almost like to have two reinforcement learning agents with two different log probabilities, and then if you have something like that, it's easier to do something like neg log probs, and then just say this particular step equal to torch tensor of the neg probabilities. It probably doesn't make sense, but like if this is a list, it's not gonna work. And then what I did is to say, so here you have y, right?
Mm-hmm.
And then what if you do something like this? So instead of it being itself a variable, see, this is the problem that I was having. So I was converting a list into a tensor, but then it doesn't give you this warning anymore. So even though your gradient is lost,
It just continues. I see.
it just continues. Yeah. So that was
That's dangerous.
yeah, that was an annoying issue. I should probably, I don't know, fire up an issue in the Torch repository. Just let them know that sometimes people do this, and you should warn them.
Okay.
But yeah.
Interesting indeed.
Yeah. But yeah, that's about what I have for the week. I'm trying
Good
out.
job.
Yeah, thanks. I mean, you too. It's all yours, man.
Copy paste. Google Foo.
Yeah. Oh, by the way, something fun. I modified the Q-learning formula in Wikipedia.
What?
I didn't know that you can just go ahead and modify it, but it turns out you can. So this is my formula now.
Oh.
Which by all means, guys, take a look. I just want to make sure it's correct. Did I just okay? And I can show you what the old one looks like. I was so surprised. I've always thought that they would require you to be approved by like by like a mediator or something. But it turns
No,
out
no,
no.
no.
How do you just open this? Right, right. There it is. Yeah, this is the old one. So to put things into perspective, you see the formula? Oh, actually, this is already the modified one.
The same. Mhm.
Yeah, this is the old one. So it's interesting that they're using the 1 minus alpha thing and the plus and alpha times the thing on the other side. It's not really that common, I think, especially when you do implementation, and I don't think it makes much sense.
It's well, if you have to be rigorous, you need the one minus alpha. But
What?
I guess in practice it doesn't really matter much, so that's why you don't
Why?
see it.
Why did you say that?
Hmm?
Why do you think you
Oh,
need the 1 minus alpha?
you want it if from the theoretical aspect. I think it was developed somewhere in the Richard's book, the Oral Bible.
Right, right. Oh, they Sutton and Bardo, they use this 1 minus alpha thing?
Yes.
Really?
Mm.
It's interesting. Well, I think this
Or
makes more.
maybe in the early like deduction of the Q learning algorithm, they always use, at least in the theory, they use the one minus alpha for the old value and
Mhm.
the alpha for the well the target. So when you sum it all together, it gives one some kind of
Right,
trade-off.
right. Well, this is essentially the target, right? Um,
I guess.
and then if you put the Q on the other side, this is a temporal difference. That's why I think it makes more sense because
Ah,
you can see what the temporal difference is. And it makes more sense if you want to do an introduction to the DQN where let me share the slides real quick. So this, I don't want to do that. So if you ever want to do a presentation on the DQN to, I don't know, some undergrad, this will be a great PowerPoint to use. So for the DQN, this is essentially it. Instead of doing this using the alpha and the old value to update, you're minimizing over the temporal difference, right? This is what the DQN does.
okay. Mhm.
Yeah. So by
Yeah.
using this formula, for me, it makes more sense because you see the temporal difference, but also when you update it, when you talk about DQN, it's much easier to just say you're minimizing the temporal difference. That's all.
Okay.
But
And
yeah,
we don't. I think you minimize the error between. Is that the temporal difference?
yes, this is the temporal difference. The L, this part is the temporal difference. So not the learned value. I guess it could also be interpreted as the learned value, but I took it out as in the latest edition.
Ah, okay, I see. I see. Great.
Yeah,
You're
yeah.
now a contributor of Wikipedia.
Yeah, yeah, that's pretty interesting. I never, I've always thought contributing to this or something would be very complicated, require a lot of work, but it was really just as easy as modifying a few LaTeX formula and hit submit. No one is even there to check on you or something.
Mm. There's still a lot of algorithms that do not have a Wikipedia page if you feel bored. you can always help out.
I don't know if I have a lot of time for that. I'm already overwhelmed with a bunch of my own things. But yeah, I think that's pretty much all I have. Let me think if there's anything else that I need to mention. Nice, it learns. Yeah, I think that's that's gonna be all I have.
Okay.
Do you guys have any further comments or questions? Okay, I'm gonna. Do you have something to add, Nichu?
No, nothing much. It was a good thing. I haven't contributed anything much, but I'm not a big expert kind of you guys, so I'm just getting my hands on this reinforcement learning. So
Oh,
maybe,
welcome, welcome.
yeah, maybe from the next dev cycle, maybe I'll try to contribute. I'm just going through the clean RL repo and trying to understand the different things.
Mm-hmm.
So
Yeah,
yeah,
yeah, that's great.
You already checked to the new OpenAI's PyTorch DRL
Yes,
implementations?
yes, I was gonna mention it to you because in their PPO implementation, they do have that target KL, and
Yes.
let's take a look actually. But I don't think it's more of they just put it in, they just implement it into PyTorch without fully committing into PyTorch, if that makes any sense. It's like they're keeping some of the structures of their code, but it's difficult to read. Like yeah, like for example, they still do this kind of, I don't know. It's not very straightforward to me.
Uh,
Yeah, you see here,
uh,
if KL is greater than 1.5 times target KL, then break. It's pretty
it's,
interesting, actually.
it's the PyTorch version, right?
Yeah.
Okay.
Yeah. By the way, how did you do the update? So, sorry, the transition. Because I remember in a lot of implementation that I've seen, they actually
Yes.
use some sort of buffer. It's not exactly replay buffer. It's like a special purpose kind of buffer where
Oh, yes.
they still keep track of the indexes.
The indexes.
Sorry, the sequences, I suppose. It keeps track of the trajectory instead of just transitions.
Uh, I think they need to keep track of the trajectory to be able to, once the episode is done,
Uh-huh.
to go back and compute the different GAE advantage and the
Yes.
discounted return.
Yes.
So that's why.
Yeah, I think so. And after that, I think they just randomly sample from the
Yes.
advantages and observation actions and blah blah blah. But they needed the trajectory, the complete episode to compute the GAE. They couldn't just randomly sample 32 transitions and then calculate the GAE.
Yes. I think that's pretty much what I do.
Well, that's pretty much what you did. Nice, nice.
Yeah.
Yeah, I think in a
Oh,
couple implementations that I've seen, they do very similar things, and yeah, it makes sense, I suppose. So
wait.
yeah, so
Yes, go ahead.
instead of optimizing over the entire trajectory, they're sort of randomly sampling time steps of the trajectory or the episode, and then to optimize behaviors over those particular time steps for k number of times. That's a kind of interesting idea.
Oh, indeed. I see. Also, I see they are somehow averaging the KL before actually using it. This
Averaging
is
what?
in the online 268. There is a KL equals MPI average of the KL.
200 and what?
268, like
I see.
where they break the KL. They
That's-
actually average it before using it in the condition.
I see. I see. That's
So
interesting.
maybe
What? Yeah. Go ahead.
so you go instead. I'll just think it a little bit further.
What is the MPI anyway?
I think it's just to use multiple processors to do the KL.
That's such a weird thing. It's like PyTorch. There's a built-in just MP.
Okay, so maybe it's some relic of the TensorFlow implementation.
Yeah, it seems to be the case, but that's just like I said. It's like they're using PyTorch, but they're using the mindset of TensorFlow. it's kind of awkward, you know. And MPI is, I think, regrettably something that doesn't necessarily work with Windows.
Windows.
I mean, I'm not using Windows. I just remember when I was doing it, that was a huge issue for me. Like at some point, I'm pretty sure you couldn't install baselines on Windows.
Really?
Yeah. And then I switched to Linux. Happy afterwards. Well, there are situations that kind of sucks, but overall, it's good.
I see.
All right. I think that's going to be it. Thank you guys for coming. Wish you guys have a very good weekend. And
Likewise.
hope
Yeah.
to see you guys next
Thank you.
Yeah.
Thank you, Costa Rosa. Thank you. Good night. Bye.
Yeah, thank you so much. All right, I'll see you, Rosalind, and need you.
Yes,
You
sure
guys.
thing.
Thank you.
All right, have a good weekend. Bye.